Good morning, everyone. Thank you so much for joining us for our webinar today, Better Controls for Big Engines. I'm Ricky Lim, Head of Commercial and Product Strategy at FW Murphy. I just want to say it's really great to have all of you with us today. We're excited to spend this time talking about how better controls can make a big difference for your larger engines, like the VHP series, helping you improve performance, reliability, and mission compliance for your operations. Before we get started, just a few quick bits on housekeeping. First, your mics are muted, so we make things clear for everyone. But we want to hear from you. So if you have any questions, please type them into the chat at any time. We'll have a dedicated Q&A session at the end, moderated by our very own product manager, Calvin Dill. He will be collecting your questions and making sure that we get to as many as we can. This session is also being recorded, so if there's anything you want to watch again, send it to your team or just reviewing it at your own pace. It will be available on our website and social media channels very soon. All right, let's get to the good part. We're thrilled to have two fantastic guests with us today who really knows this industry inside and out. First, we have FW Murphy's very own Jeff Elkins. Jeff leads the sales efforts for EICS systems, focusing on large engines. His responsibilities include educating and supporting our customers, as well as defining the future EICS systems. For the last 30 years, Jeff has been focused on the industrial engines market in training, services, and sales. He started his working life in the U.S. Navy, and prior to joining FW Murphy, Jeff held positions at Inyo Waukesha, Innovation Controls, and Stewart and Stevenson. He also holds various technical certifications for Waukesha gas engines, Deutz diesel engines, and the Navy. Next, we're incredibly excited to be joined by Mr. Colt Gibbs, who I'll be interviewing later in this session. He will be sharing his first-hand experience using the EICS VHP systems in the field and offering some valuable insights from a user's perspective. Colt joins us from Summit Midstream. He brings to the industry 18 years of experience in the oil and gas field. Colt started as an operator and worked his way up to a lead mechanic today. He has worked for companies like JW Power, Archrock, Tops, and a few smaller private companies. So let's get things rolling. Jeff, over to you.
Great. Thanks, Ricky. Appreciate the introduction this morning. So let's get going. Good morning, everybody. Thanks for joining us today. Appreciate your time. And let's talk about engine controls. So, for those of us that are on the call that don't know what EICS stands for, so that is the FW Murphy Engine Integrated Control System. We created the system back in 2011. Initially, it was created on the smaller engines, Cat Cummins, some of the old Waukesha models that Arrow had purchased over the years. Really, the initial ask or the initial kind of goal of the project was to create a system that would be as user friendly as possible. And so, at least here in the States, what that means for us is an engine that can stay in emissions compliance continuously. So that was really the goal of the creation of this product. So, one of the things as we were thinking about, what are the benefits of this product, and we think you have to ask yourself, is your organization throwing money away? When you think about the VHP and how it is today, and you look at the fuel system and you look at the throttle system, the speed control system on the engine, it really hasn't changed in almost 60 years at this point. And so all of those pieces take technician intervention to stay in the top, state of performance and tune. And so if your technicians are having to drive, long stints to get out to the sites and make adjustments on those engines, is that the best use of their time? We all know that, run the roads out in the Permian, maybe up in Wyoming, Montana, lots of sites are far off the main highways. And, are they safe out there at night? Are they, getting home to their families safe? Are they spending much more time than is necessary just keeping your engines in a state of tune? So, ask yourselves that as we go through this morning. How much time are your technicians spending getting your units ready for emissions testing? Because that is one of the goals of this product, is to minimize the need for doing that. Um, what happens when your gas composition goes up and down? Today, with most systems, what you're looking at is taking a gas analysis, taking that composition, inputting it into the system, and then the system operating off of that original gas composition. If your gas composition travels up, travels down, is your unit still in a proper state of tune? Is it running at its most efficient? I know some companies already are shifting to having, site located gas analysis systems. But for those that don't, are you even aware? Are you aware that your gas composition has changed? And is your engine still running at its most efficient point? And are you passing emissions at any given time? Could a state employee walk out and check emissions today and you would be in compliance? Again, old technology that's on the VHP today, how much time do your technicians spend adjusting those pieces or troubleshooting, um, faults on those engines? And ultimately, like I mentioned, is your engine running at its most efficient? What is the cost of your downtime? What is the cost of the technician's downtime or just windshield time, all the driving time? And so ask yourself, are you throwing money away by having these antiquated engine controls on your engine? So if you have an older 7042 natural GU 7042 GSI or 5794 7044, we have the control system for you. We have a fully um, vetted, calibrated system that can fit on any of those engines today and really improve the operation of the unit. We kind of did this for fun, but is it time to trade in your bias ply tires and carburetors, right? I mean, you think about it, and I think you'll see as you look at this technology that it is a totally different technology than what the customers have been used to running VHP engines. I mean, in most parking lots and most places in the United States, there's not cars with carburetors and bias ply tires unless you just happen to have an old classic that you're keeping on the roads. But otherwise, it's all fuel injection and state of the art radial tire technology, right? So is it time, right, in the natural gas industry to make that leap to the next kind of evolution of the control system for these engines? I want to start by giving a little bit of a history. Like I mentioned, we initially created the EICS system all the way back 14 years ago now, and it was originally created on the smaller engines. Probably many of you recognize the engine over there on the left, and ultimately the system was so well received in the industry that the industry really demanded that the OEM remove the control system from their engine. So either install EICS from the factory or give us a bare engine so that we can install EICS ourselves in the field or at the packager facilities. And ultimately, that's what happened. There was an outcry from the marketplace that, hey, this is the better system. And if you want us to continue purchasing and using your engines in the compression field, this is what we want to be using. And ultimately, twisted the arm of a very powerful OEM to make that happen. And so, from the beginning, the EICS system has been very well received. Initially on the smaller engines, we approach things a little bit differently than the way we're doing them today on the bigger engines. So initially, we would have done that with a direct acting electric pressure regulator. So we would have eliminated the older style regulator and um, added a very quick acting electric regulator, and then added a electronically controlled throttle onto the system. We also included, what I would call a unitized catalyst system. It was a sealed system. It included a full sensor package, so oxygen sensor, temperature sensors, so that you understood the health and whether your catalyst was operating at peak efficiency. And then ultimately, the way it was serviced was you would pull the whole unit out and just replace the whole unit as a complete package. From the beginning, we were offering this as a complete kit, standalone kit. So you get, ECU, you get an HMI to look into the parameters, the operating parameters and health of the engine. You get all the brackets you need, all the hardware you need, the harnessing you need, all included. And in addition to that, we were including our, excuse me, our smart coil technology on the engines, which allows us or gives us the ability to monitor live the kilovolt output across the ignition system, the coil, the secondary, the spark plug, so that live time on the screen you can monitor the health of your ignition system, right? All with the goal of being able to, more accurately predict when you have maintenance due on the units versus just doing it on a time-based schedule. So what we realized is as we got into larger and larger engines that ultimately these smaller pieces that we had created for the small engines were not going to be sufficient. So we were going from, sub 200 horsepower engines in some cases all the way up to 1700 horsepower. And initially some of the solutions were just like daisy chaining or running in parallel some of those smaller solutions, and ultimately wanted to create a new technology that could individually or with just a couple units handle the larger engine fuel and air requirements. And so ultimately that's what we did. If you see, we've got the earlier generation on the left, you see, kind of parallel assemblies in some cases. And then ultimately we created an entire new technology, and that is our current MFA and MFG valves. And so what that gives us is it gives us two valves, multiple sizes, where we can control very precisely the flow of air and the flow of gas, or air and gas in some cases, across the engine. And so, you may think, well, this is just a fancy electronic butterfly. Kind of true, I guess, but it's really much more than that. And so beyond just being a control device that is, um, monitoring or controlling the flow of air and gas into the engine, what you get is a very robust system that is, has many items housed inside of it for, not only the purpose of controlling those air and gas streams, but also monitoring and measuring the flow of air and gas across those units. And so, like I mentioned, we've got some different sizes. Today, the VHPs, the 12 cylinder specifically, is using a 50 millimeter gas valve with a 105 millimeter air valve. It uses a set of those per side. So there's two MFGs and two MFAs per V12 engine, which gives us some really nice advantages that I'll, talk about as I, kind of show you more about what's happening specifically on the engine. But built within each of these units is an individual sensor package housed within the unit itself, right? So beyond just the control of flow, we're actually measuring the pressure coming into the valve, the pressure leaving the valve, the pressure across the butterfly, temperature of the media that's passing through the valve. All of those are being live time monitored. And ultimately what that does for us is it allows us to measure the mass flow of the media that's passing through that valve. And we can use that that information to do other things within the control system that until now really haven't been possible. And then I think what you're going to see is it's pretty exciting stuff. And so, again, it's a control device, but also a measuring device at the same time. I mean, one of the neat things as a result of the sensor package in the unit is you have a real time fuel flow meter built into your engine now, where previously you see a lot of that, at least in my experience on a site. You may see it across, multiple units. With EICS, you will individually know the fuel flow and the consumption across each individual engine that has this system on it. Um, just a few comments on the right there. I mean, it is made to be durable. At this point, it's lasting at least the life cycle of an overhaul on the engine. We'll see, as time goes by, some of those things you don't understand until you just do the time, right? It's 40, 50, 60,000 run hours, and we just got to put the time in. But uh, super durable shaft seals on the unit, high temp ball bearings. The system actually has a coolant passage in the casting. In most cases, that's not used, but that's there in case you have a higher temperature gas that's flowing through the system. We can actually divert some coolant going through there to help keep the unit safe. Um, and then again, there's some additional design features in the unit where we're uh, controlling against backfire and we have some detection capabilities, but also active protection to help, keep the unit from being damaged in the case of a backfire. So beyond these items on the VHP, we needed to we've what you're going to see as I go through the engines themselves is we've eliminated that old traditional mixer. So what was typically an IMCO product that was diaphragms and springs and what have you, kind of carburetor slash mixer. We're going to eliminate that, and so we've just got two straight bore valves here. We need a way to mix the two, the air and the fuel. And so what we've done is in a very kind of trick and simple way, we've created a fixed blade venturi that fits in the system. What you can see there is on the bottom of this diagram, excuse me, let me pull up my pointer quick. So this here, in a typical installation is where your MFG is. That feeds up to your mixer. That's this piece here. So again, fixed blade venturi, fuel comes in here, air coming out of your after coolers and from your turbochargers is passing through here. And really what that's doing is just creating this mix. So to come up with the, kind of most optimized design, we did a fluid dynamics study on it. And so the dark blue over here on the right is your air, the red's your fuel, and then ultimately we have a very well mixed charge that's then going to pass to what is the MFA sitting up here and ultimately up into the intake manifold of the engine. All of these bits here, these cast piping bits, are all included in the kit, so there's no need to have to figure out that. In general, there's a little bit of adaptation that needs to happen from the air pipes coming from the intercoolers down to the mixer pipe here. But other than that, all these pipes are inclusive in the kit and make for an easy installation. So one of the things that having those valves in the system does for us is it ultimately gives us the capability to calculate the BTU of the fuel that's running in the engine and passing through the engine. And so this is really where, in my opinion, many years in this industry, like this really steps up to the next level. Today, like I mentioned, I mean, I'm starting to see more and more customers have on-site fuel analysis, but the fact that you have an engine, it needs a control system anyway, and we're going to put a control system on the engine that ultimately gives you the capability to understand what the fuel BTU level is at any given time, I think is really, kind of the next evolution of control systems in our industry. Uh, Took a picture of, engines in the field for this presentation, so excuse the dirty nature of this, but a lot of our customers, again, are doing these as field retrofits, and so this was in process as the engine system was being installed. I noticed a few missing wiring clips and things that hopefully were installed before the engine got started. So how does that work? How does real-time BTU work? Like I mentioned, the MFA, the MFG are, full of sensors themselves, a complete sensor package in them. And so what ultimately happens is a combination of the readings that those valves are getting and then the outbound oxygen on the unit gives us the ability to then calculate the BTU that's passing through the engine. And so this is a, a patented technology with these valves. Um, and at this point has been released on a number of models. So, for those of you that have VHPs that are saying, well, heck, I've been operating for a while and I've never heard of this. Ultimately, with the VHP, it wasn't released upon the release of the VHP EICS system, but it is now available. And so it's something, if you already have EICS and you're sitting in on our presentation today and you want to consider, potentially using this functionality, just reach out to the FW Murphy sales team and we can talk with you and look at your operation and see what it'll take to go ahead and turn that on. Ultimately, it was built into all the systems. Um, it was still going through some fine tuning initially, but as we sit here today, it's been released to the field on 3 other engine models and has been working really well. And so we're planning to be using it on the VHP. And again, if you already have VHP and this is something you think you'd be interested in, just reach out to us and we can talk about that. And so ultimately what it does is we're taking that mass flow information that we're gaining from the valves, we're measuring the outbound oxygen, we're then understanding the BTU of the fuel running through the engine. And what that allows us to do versus a fixed input is we can real time manipulate some of the settings on the engine to allow it to be at that most efficient point. And so, the things that we're going to look at if the BTUs do make a change is we're going to be adjusting your air fuel ratios set point, right? Having that system run to the most ideal set point is what will ensure that we stay in emissions compliance. And so if the fuel uh, BTU swings a great deal, potentially we're changing that. The other thing that we're going to do is change the NOx setting, right? Where am I sensing detonation? Where am I looking for detonation? If I'm at 900 BTUs fuel, it's going to be different than if I'm at 1200 BTU fuel or 1350 BTU fuel. But the same is true going the opposite way. If I am at 1350 when I set this engine up and then I shift to 900 BTUs, I want to advance the ignition timing. If I leave it in a more retarded state, chances are I'm building up more heat in the cylinders. I'm probably impacting fuel economy on the engine. And so having the ability to understand what the BTU levels are at any given time and then on the fly make adjustments to the engine again will lead to just a more efficient operating engine. There is one other parameter that we're going to potentially change based on the BTU, the understanding of the BTU, and that's load limiting the engine. So, I mean, for us, it's got to be really high. You're talking probably 15, 16, 1700 BTUs. I don't see a lot of that in typical field gas operations, but we know it can happen. And as we were developing this system, ultimately what we did was we tested from 900 all the way through propane. So that was kind of the most straightforward way for us to understand, kind of all operating parameters necessary for the engine. And so we would start at 900, we would sweep the fuel all the way to pure propane so that we understood where, ignition timing, air fuel ratio, all of those things needed to be. We would, have a clear understanding of that and make the mapping for the engine at every point along the way. So basically covered this again. Why do you want it? Well, again, the engine's not going to be where it needs to be if I don't know what that is. With that fixed, that typical fixed, I have 900 BTUs, I have a 75 WKI, I have an 80 methane number, whatever that is, it's doing the same thing, likely, maybe not in as a sophisticated of a way, but it is then setting up maps which are saying, hey, here's where ignition timing needs to be. Here's where my air fuel ratio set point needs to be, right? It's doing that. But the difference is we're doing it on the fly and then we're making changes to it if the composition of the fuel changes. So So, again, kind of what is the EICS specifically for VHP? Again, this was the early system that I showed earlier in the presentation, DPR, which was the direct acting regulator, et cetera, et cetera. So this is what the VHP system itself looks like. So, like I mentioned, dual MFAs, dual MFGs, dual mixers. So each side of the engine has its own air and fuel gas train. We're actually running two ECUs. I've heard some people in the field kind of make comments about that. I'll tell you why we're doing it. So our ECUs actually house the ignition channels as well as the detonation sensing channels. And so while other systems may have one ECU, in general, they have multiple other boxes as well, right? And so we're basically taking those quote unquote other boxes and combining them as part of our ECU. So we run an ECU mounted to the side of the engine per side, driving those systems on each side of the engine. And then we have very fast CAN communications that are linking those two ECUs together and then back to the panel. So really all of our decision making and all of the controls processes within the system are happening in matters of milliseconds typically. So, like I mentioned earlier, kit's going to include everything you need to easily install it on the engine. This is some of the other stuff kind of not shown on the previous picture. Like I mentioned, brackets. We include a full sensor package in the engine, all your detonation sensors, all your manifold air pressure and temperature sensors, oil pressure, coolant temperature, oil temperature. All of those things come standard in the kit, all the piping necessary to make those adaptations of the MFA, MFG, the harnessing all comes in the kit. We have three different styles of coils available in the kit, whether it's flange mounted for your 7044, 5794, it's manifold mounted for your 7042s and older engines, or we have also a shielded coil available. So that's all standard in the kit that you purchase. And in many cases, like with the coils, for example, going to be engine specific. So we'll have kind of a main base kit, which is all the common components, and then we'll have sub kits, which are 7042 kit or a 7044 kit, and then that will differentiate things like flange mounted coils versus manifold mounted coils. We do have a handful of options that are available with the kit. I guess maybe I got corrected the other day on this. So we have a product that we'll talk a little bit more about as I continue on the presentation, which is our M-Link gateway. So we have the ability to remote monitor and troubleshoot these engines, have a robust troubleshooting tool as part of that package. So we're actually including, so not optional, including the M-Link as part of our kit, as well as a year's worth of connectivity. And that's maybe more than giving you remote access, gives us access so that we can help ensure that, once the EICS is installed, it's up and running, it's running well, and if there's any troubleshooting guidance or help needed, that we can get quick access to the engine to help you ensure that everything's running smoothly. We have a separate what we call a mini panel. So if you have a established panel, you're not going to make any panel changes on the unit. We can add this panel to the side of your existing panel. It gives you start stop, emergency shutdown capabilities, as well as houses the wiring coming off the engine and the HMI specifically for the engine. Here more recently, and this is kind of as I show here, an upcoming release. So we've taken our MX4 IO expansion module and we've developed the capability to have all your individual exhaust thermocouples, main bearing thermocouples, and we're also working on a crankcase pressure sensor. So some additional sensors that didn't originally come with the package. I think the idea was originally a lot of customers who would be doing these as field retrofits would already have that capability built in. And so I think a lot of the customers were like, well, I don't want to pay for something I already have. But one of the things we saw as valuable to both the customers and to us is if you're using our M-Link product and remote monitoring your engine, but you have all of your thermocouples going into an existing controller in the panel, TDD, TDXM, those sorts of older Murphy units, you then didn't have capability to see those temperatures remotely. And so by using this MX4 module, we'll bring that information back into the main HMI, and it'll be broadcast through our remote system as well as into our EDIS troubleshooting system. So one of the capabilities our system gets with our M-Link product is a really robust troubleshooting tool that we call EDIS. It allows for completely remote sessions. We use this a lot, both for development, product development, as well as troubleshooting, where we'll get a team of guys literally on a Teams call. One of the team members will open this gateway into looking at the engine, and then that way every one of us can look at it at the same time. And so it gives you the ability to have many people helping with a troubleshooting or tuning of an engine that would have been capable prior to that. So gives you the ability to plot and graph and save those graphs. If you have to do troubleshooting, like I mentioned previously, in the bottom right corner there, the unit has real time, instantaneous fuel flow, as well as totalizers of the fuel usage for the hour, the day, the month. That's all made capable through the MFA and MFG that are part of the system. We can include in the M-Link side of things, we can include compressor monitoring. So anything coming off the skid that's, Modbus mapped, we can ultimately show on the unit, and then you get the geolocation capability as well to know where all your units are set, and kind of instantaneous the status of them: red, yellow, blue, green. Is it running? Is it shut down? Is it a warning state? Right, all through a simple view in the system. So I've told you about where we started, talked about the components that are in the VHP. So now let me kind of show you on some simplified diagrams the changes we're making. And so For those of you that have been working on VHPs for many years, this probably looks pretty familiar. You've got uh, excuse me, you've got some sort of throttle control that can be air actuated. It can be an electronic throttle controller. It's ultimately driving an electronic governor, Woodward style governor in many cases. And then you've got a number of linkages, right? So you got a whole lot of shafts, linkages, joints, bolts, that are all ultimately driving, um, the butterfly on one side of the engine, right? That's got a shaft that connects it to another butterfly on the other side of the engine. You've got a couple of ounce regulators feeding fuel to the old style carburetor mixer full of diaphragms and springs and what have you, right? And that's feeding fuel up to um, ultimately up to these butterflies. So this is where I see a lot in the field. If these are mismatched, ultimately one side of this engine is going to be working harder than the other. So keeping these in a state of tune between each other to ensure kind of a more equal um, load characteristic on each side of the engine is really critical. So all of these things need to stay in kind of consistent adjustment. And if you have any hope with this system of meeting emissions at all, chances are your technicians are going to be out daily, if not weekly, making fine tuning adjustments to this system to keep it in the highest state of tune. Now, if your fuel's moving on top of that, if your BTU levels are moving on top of that, chances are you're not going to be in tune at any particular given time, right? Older systems, in addition to that, many of them wouldn't have had detonation sensing. Many of them wouldn't have had exhaust temperature sensing. So we're giving you a lot more capability to monitor the health of your engine and ensure it's running at kind of peak performance at all times. So we went from there, that mechanical system, and then from there, excuse me, converted into the kind of an earlier system that I'm not going to talk about. Ultimately, a lot of these customers, a lot of you today probably still have ESM1 and you're trying to decide what to do with that. So our electronic governor controller shifted to an ECU. We've now eliminated the gear driven governor in favor of an electronic throttle actuator. But ultimately, we're still driving those 1967 throttle butterflies with all the linkages and all the shafts. And then on the back end over here, we've added a stepper motor to our ounce regulators. For those of you that are on the line, if you've ever had to replace one of these or replace a main engine harness, one of these throttle actuators, these pieces are expensive. At this point, many of the components of this system are becoming end of life. And then ultimately on this system, emissions are based on oxygen coming out of the turbocharger, so pre-catalyst. But really all that's doing is sending a signal to these stepper motors to make small changes to the gas between the regulator and the mixer. And so very slow acting, not a lot of range built into it, and ultimately, pretty limited on what it can do. And compare that today with where we're at. So here's what EICS looks on on a VHP. Like I mentioned, dual ECUs, feeding a CAN signal to our MFA and MFG. The MFA is taking place of the throttle on the system, right? The mixer's taking place of the old carburetor mixers. MFG is uh, precisely controlling fuel going into those. So while we are still using an ounce regulator, it can be a simplified non-pilot actuated regulator. All we need is a good supply, steady supply of fuel coming into our MFG and supplied into the engine. You'll notice one of the things that's really different, where, as I mentioned previously, you have to keep those throttle butterflies in a state of tune to ensure that load is equally distributed across the engine. We're going to do that real time, right? So the signals coming from the ECUs are going to keep the manifold pressure on this engine within a small variance of each other. Typically, what I see on operating engines is within about a tenth of a psi, and so we're going to ensure at all times that that engine balance is in tight tolerance. Where previously on the mechanical system, or even into ESM1, and frankly even into ESM2, if those butterflies are out of whack, that balance on either side of the engine is no longer in place. So at this point, I've talked a lot about history, components of the unit, how the unit looks on the VHP, what it replaces previously. So now I'm going to go ahead and shift over, and we're going to hear some real experiences from a customer who actually owns and uses EICS on VHP today. So with that, Ricky, take it away, sir.
Awesome. Thank you so much, Jeff, for the fantastic technical deep dive on the EICS VHP system. Now let's shake things up a little bit. I'm excited to bring Colt back into the conversation to share about what it's really like to work with the EICS system. Colt, can you hear me?
Yes, I can hear you just fine.
Great. Let's jump right in. So, Colt, let's start from the beginning. What was the main problem or need that led you and Summit Midstream to take a look at a new engine control solution?
So our main issue we were facing is just keeping our engines running in compliance with the emissions regulations. Here in Colorado, they're ever changing. The demands are 24/7. We had problems with our. We set them, spend a day or two setting them where they're supposed to be, and they would stay there for a while, and then they just like everything else, it changes. Where we have this EICS system, you set it, you can walk away, it's gonna be the same thing. It always is.
Perfect. And I'm sure emissions compliance is a focus for a lot of our audience today as well. So, when you look at solving the problem itself, what were the choices that you had, or what were you looking at in terms of the selection process? What other options did you have during that time?
So we were looking into it. There wasn't a lot of options. We looked at like EMIT. We were using some of the electronic EPC 100s, and then we looked at the Murphy EICS system, and it seemed the new kid on the block almost. It seemed like a updated way to go.
Gotcha. So you were looking for sort of a newer technologies to solve your needs, and what were there any other options, or I guess reasons why you chose the VHP system?
Um, ability the real reason we chose the EICS system is just the ability for the control system to handle the BTU fluctuations coming into our units, keeping them running consistently and in a safe manner, where they would stay in compliance 24/7. And the added benefit was it also gave us an ignition upgrade on our over the OEM system we were using at the time.
Gotcha. And would you say that the emission compliance were some of the biggest improvement that you've seen since adopting the system?
Yes, yes. We went from constantly battling it to just being able to monitor it and make small changes if needed. And the unit were staying roughly right there at the limits where we were set them. And it also, yeah, it also got rid of some of the repair costs. Really helped that too because the engine stayed running consistent 24/7.
That's wonderful to hear. And one last question, if people always say hindsight's 2020, right? Would you, since we're talking to a bunch of audience here, like there's got to be a question about is it a good fit for me, or how do I know if it's a good fit? If you were to look back, like, and if somebody asked you, like, who would be a good fit for an EICS system in your opinion, what would you say?
So what I found is anyone who runs a gas compression or gas combustion engine who wants or needs to run more efficiency, whether it's on the emission side or just reduce the operating costs, keep maintenance down, the EICS system is a good option.
Gotcha. Sounds like getting more reliability, reducing maintenance, it's also a good candidate.
Yes, sir.
Well, thank you so much, Colt. I know you're going to get more questions during the Q&A session. Really appreciate you sharing your experience with us. Let me send it back to Jeff to give us a quick summary of what we talked about today. Jeff? I think your people can't hear you on your mic, it sounds like.
Can you hear me?
Yes, there we go.
Okay, sorry, nothing changed. So yeah, I don't know where I cut out, but yeah, we can give you an indication of fuel property swings. Like I mentioned as I was showing the diagrams of the VHP, we're no longer using a diaphragm device. We've removed all of the linkages. The mechanical governor is gone. All of those things have changed. We've much reduced the airflow restriction across the engine. As relates to governing, like I said during the slides with the diagrams, we're controlling both of our MFAs. It's controlled quickly. Literally, the butterfly is moving within milliseconds. The left and right bank are staying synchronized at all times for best possible operation. Um, we've got some additional tools I haven't even hit on, but through our EICS system, you've got compression check modes. You can fire ignition coils individually to help and assist troubleshooting. Lots of built-in tools that, as an ex-technician myself, I think the technicians are going to be really excited about. And then, like Colt mentioned, we've got our smart ignition system on there where we're live time monitoring kilovolt output across the coil and the secondary, or the spark plug tube and the spark plug. And so literally you can see if you're have a cylinder's ignition system starting to wear out and in need of maintenance. I mean, one of the first times I got to visit an EICS equipped engine, I walked up to it, and one of my colleagues had kind of beat me over the head to immediately look at kilovolts on the ignition system, and I saw that one side of the engine was all the same and the other side of the engine was all the same, but the two sides of the engine were very different. And what we come to realize is that a different technician had gapped one side of the engine versus the other, and so we were even able to recognize that through our smart ignition system. So, in kind of summary, let's give your old VHP some new life, especially you've got a 42G that you want to keep running, a 42 GSI that you don't want to make big changes to, but could benefit from, more reliable emissions and some additional safeties. So let's get rid of your actuators, your carburetors, your linkages, and rest easy knowing your engine will adapt to a broad range of fuel compositions. Your engine will be safe, it'll run efficiently, and exhaust emissions will be in compliance. So, yeah, thank you, everybody. Again, appreciate your time. And now we're going to turn it over to Kyle Van Dale, who's going to help us field some questions from the audience. So, thanks so much.
Thank you, Jeff. Welcome everybody to the Q&A portion of our presentation. And please allow me to direct your attention to the Q&A icon found at the top of your window. It looks like a sort of a comic book conversation bubble with a question mark in it. And if you click on it, it'll open a sidebar, at the bottom of which will be some green text that if you click on, you'll be able to type in a question and submit it. Now, if we run out of time and don't answer your question, do not fear. We will be reaching out to you to take care of that at some point after the presentation. All right. So, Jeff, what are the main differences that you would say are between an FR2 EMS system and a EICS system for VHP?
I'm not sure I understand the question. Hit me with that again, Kyle. Sorry.
Well, what would you say are kind of the differences between a FR2 EMS system, I guess the Waukesha system,
Oh,
and
are
an
we talking
EICS?
ESM2 maybe?
Yeah,
Okay,
I think
okay,
so.
got it. All right, I'll answer that. And so, really, with ESM2, the big change between ESM1 and ESM2 was um, the elimination of the stepper motors off the regulator. So Waukesha went back to a mechanical regulator, Fisher 99. And then instead of using the stepper to trim fuel, going up to the mixer slash butterflies, they put an inline flapper valve, basically, for lack of a better term. So an electronically controlled, flapper. And so again, they're they're monitoring pre-cat oxygen, and that's telling that flapper valve to trim the fuel still going into the old mechanical mixer and up to the butterflies. So Waukesha does have a package, a catalyst package that would then shift the oxygen to the post cat oxygen. But as part of EICS, that's all included in the system. So we're not demanding that you use, our catalyst or only a catalyst of our choosing. Certainly, we can recommend one. But so, ultimately in today's VHP system, you still got that traditional mixer flapper, which, as per my presentation this morning, we are eliminating. On top of that, if you have a 42G or you have a 42 GSI, there's no ESM2 for that. ESM2 is not being created for that. Waukesha's preference is that you update the engine to the more modern configuration of the engine. And so, not that that can't be done, it absolutely can be. And in a past life, I did that, but it's at a very large expense. So the EICS is going to be a much better price point and include much more modern features in the system. So I hope that answers the question. And if not, let us know and we can reach out and have a deep dive discussion about it.
All right. Um, do we have an estimated installation time for doing one of these? And also, does one install it themselves? Or do they need to hire someone else?
So, I mean, I think we feel like if the site and the installation is well scouted, 2.5 to 3 days is kind of typical. Mechanically, in my opinion, it's a pretty straightforward installation. I mean, you have a strong mechanical technician; they should be able to, do all the mechanical stuff. We've got a, nice, guide that goes along with the system. Sometimes the integration with the panel, depending, kind of the vintage of the panel, the complexity of the panel, that can be, something where you need some expertise to do that. We have training courses that we put on a regular basis. If you connect with anyone on the team, we can get you the schedule for that. We just put on a really nice class up in West Virginia with our team and a number of in customer folks. So it's ultimately it's something that an in customer could do. I would think maybe the first couple times around, having the channel partner involved, to help assist and bring expertise to the site would be valuable and be worthwhile until your own staff would get up to speed. So yeah, either or, but channel partners and the Murphy team are always available to help, certainly.
All right. And we have time for a couple more, maybe two more questions. And I'm just going to go ahead and ask them. And what sort of runtime do we have on systems in the field? And what sort of remote monitoring capabilities are there? There's an M-Link that our remote modem called an M-Link is included in the kit. And maybe you can speak to what someone gets for free and what is involved with a subscription.
Yeah. So as far as runtime, we've been putting the VHP out in the field since 21, like I kind of briefly mentioned during the presentation. I mean, we're about 250 units in at this point, and taking orders every day from customers that love them and are adapting more across the fleet. In addition to that, we're adding new models kind of every day to have some of our first tests going on the cat G137 8-cylinder right now, which has gone very well and very exciting. And so yeah, at this point we're about 4 years in. So for a typical operation, that'd be probably low 30,000 hours if that's full-time operation. As far as remote monitoring, like Kyle mentioned, we include a free RM Link device free as part of the kit, as well as basically a year's worth of connection, so we can get you through that first year, make sure there's no problems, and get our folks hooked in immediately if you need help. Beyond that, if you want to use it for remote monitoring and all the available tools that are in it after that initial year, then there is a subscription fee to continue using the service. The M-Link is cellular as well as satellite capable, and so it can it can operate in basically all the areas uh, that we operate. It just shifts to the satellite if it loses a cell signal, and then if the cell signal is regained, it shifts back to the cellular, which gives you a little bit faster data stream. So yeah, all initially included in the kit, and then after the year, it's up to you whether you want to continue on with the service or not.
All right. Well, I'll hand it back to you. And on that remote monitoring, the remote support, if you will, the troubleshooting portion, that's for a year and that's free. But if you want to do some remote monitoring during that initial period or anytime thereafter, there's like a buffet of different subscriptions you can pick from. All right, Jeff, I guess that'll conclude our Q&A session, and handing it back to you and Ricky.
Perfect. Thanks, Kyle. I apologize. We have a short, small technical glitch here, but thank you all for joining us today. This brings us to the end of today's session. I want to give a special thank you to Jeff for the presentation, and especially to our guest speaker today, Colt. Colt, thank you for making the time to share your insights and experience. If you'd like to learn more about EICS VHP systems, please visit our website at fwmurphy.com/EICS and click on the large EICS large horsepower icon. If you have additional questions and want to talk about how EICS VHP can work for you, please don't hesitate to email us at fwm-info@doverprecision.com. And we also have a QR code on the upper right-hand side. We love to hear from you, and we love to hear about other topics that you might want to learn about from FW Murphy for future webinars. So thanks again for joining us today, and have a wonderful day, everybody.
Thank you.